Sometimes it's nice to add a layer of very fine particles. This is kind of a sandy or gritty layer, and it's not really large chunks like we've seen with our previous debris tests. This is more for the dirt that comes off of the fractured portion of the geometry. So we can start by taking a copy of our instance particle DOPNet. We don't need the W or orient since we're not instancing these particles. And instead of using the same scatter as we were using for the RBD and instance particle examples, we're going to need to scatter a whole lot more points. Now I'm going to make a copy of the scatter sop that we used for those other debris examples because that already has that fit function to animate the density scale set up already. And we'll attach that to our new DOPNet for this fine particulate. And we'll zoom in and rename this to DOPNet Fine Particulate. And then on this scatter sop, I'm going to emit for a longer amount of time. Instead of ending that at frame 995, we'll try emitting it until maybe 1015, although we may need to change that later. And I'll increase the multiplier to 30 instead of 3. So now we're going to be emitting far more points than before. And actually, even 30 is probably not enough. I'll try a multiplier of 50. For these fine particle sims, you're really going for tons and tons of overlapping particles. And ultimately, we're going to render them with a low alpha. So we really need tons of particles stacking up on top of each other for this sort of gritty, silty look. Now if we dive inside the DOPNet, we can delete our pop, drag, spin because we're not using any rotations on these fine particles. And on our particle limits wrangle, we can remove the parts related to the particle rotations and just leave our speed max setting in there. And for these fine particles, we want them to swirl around in the air a little bit more. So I'll use a pop wind for this example. You could also set up a volume influence instead of a pop wind. There are lots of ways you could add this sort of swirly behavior, but the pop wind is a good quick way of adding that. The default air resistance of 1 is going to be too much, so I'll turn this down to 0.1. And since our main RBD sim is about 10 units tall, I think a swirl size of 3 should be pretty good, and we'll try an amplitude of 6. We might also want our fine particles to fall a bit more slowly than the debris pieces, so I'm going to try a 0.5 multiplier on our gravity as a starting point. Now with these fine particle layers, we really need to render them to get a good sense of what they look like, but we can improve our viewport display a bit. In this case, we'll probably want to turn down the point size in our display geometry settings to get that a little bit closer to what we'd expect in the render. And we're going to use an alpha attribute on these points to control their transparency. So after that null that shows where we would be caching our points, we can drop in a point wrangle after that. And in this point wrangle, we'll set an alpha attribute on those points, and we can go with some really low value. I'll try 0.05 as a starting point, although we'll have to render this to see what it looks like. And right now our DOPNet is exporting our colliders along with our point particles. So if we go to the DOPNet and the object merge, we'll set that object mask to pop object 1. And you can see now we're just getting our point particle sim. And in the case of our instance debris, we should have done the same thing over here as well. On that instance particle DOPNet, under the object, we should set this to pop object 1. And then back on our point particles, I'll rename this point wrangle to render attributes. And we'll display that and template display our RBD geometry and see what this looks like. Now our simulation is looking cool. It looks maybe a little bit too floaty. I might revert the gravity back toward its normal amount. And for a shot like this, I'd probably animate the swirl amplitude so that it's much lower toward the end of the shot, so we don't get quite as much static swirling. But as a starting point and a test, this looks pretty nice. However, we may need a lot more particles as well, so in my resim, I'm going to turn up the density. This new sim with more points and more gravity is looking a lot better, and I did also animate down the swirl amplitude a bit over the course of the shot, although it could be animated down a bit more than it has been here. And this is at a good point to start doing some render tests. So we can pick a frame where we can see some streaks in our particles. Maybe this frame here could be good. And we'll have to render this to see what all of these particles look like with some more correct transparency and with motion blur. So we're going to test with frame 1015, and in our render attributes, we'll also need to specify a p-scale. So I'll try a value of 0.1 to start, and then I'll add a null at the end here for us to refer to in our render setup. I'll call this render point particles. Now when setting up the mantra render, I never point it directly to the null in our working area here. I always set up a new geometry container just for the render object. So create that new geometry container. I always prefix mine with render, so I'll just call this render particles. And I also make mine red so that it's obvious which nodes in the scene are just for rendering purposes. Normally I have all of my render nodes off in one section. I'm just keeping all of our debris parts down here together. Now dive inside that render particles geometry container, and we'll just object merge in that render null that we set up. So we'll point our object merge to objects, weak 6 debris tests, and render point particles. And we're also going to need a camera, so if you go back into our setup, let's frame this up exactly how we want. And then once you're happy with that framing, we can go to the lights and camera section of our shelf and control click on that camera to create a camera that matches our current viewport view. Now I'll call this camera particles. Now we can flip over to the output context and we'll create a mantra wrap. And I'll call this mantra wrap test particles. And for the camera, we'll point that to object/camera particles. And under objects, we'll remove the star from candidate objects, because if something is included in the candidate objects, then whether it's included in the render is defined by whether its display flag is set. And that's not a very straightforward workflow, in my opinion, when setting up your renders. So I pretty much always just use these forced objects and forced matte and forced phantom. In this case, we'll just go to forced objects and select our render particles. And now if we go to our render view and select that test particles mantra wrap from that dropdown and click render, we can see what our test frame looks like. And right now, all of these points are looking like some pretty large splotches. And the whole point of this render is that these are very fine particles, kind of a sandy or dirty layer. So we need to go back and decrease our p-scale. So if you go to the render attributes just before that render null, you can turn down your p-scale here. I'll try a value of 0.01 and hit Control Enter in the wrangle. So now we're getting something that looks a whole lot closer to that fine particulate look. And this is currently looking very speckly, and this will look a whole lot better once we turn on some motion blur. Now I mentioned previously that we need to use velocity blur for these changing topology renders, like when we're emitting debris. So go up to our object level and to our render geometry container, and then under the render tab, go to the sampling tab, turn on velocity blur here. And you're not going to see any changes in your render yet, because we also have to go to our mantra node and go to the render settings and turn on allow motion blur. So now you can see our particles are streaking here based on that velocity. And when doing particulate renders like this, you can't just judge this by the color channels. You can see based on this see here in the render view, we're just looking at the color channels right now. So if you hit A, that'll show us the alpha. And this gives us a better representation of what this will look like in our comp. So a lot of these areas that are pretty visible in the color channel will be very, very faint when composited because they have such a low alpha value. So when you're doing these types of effects, you really need to run lots of render iterations to tweak all of these settings, and you have to composite it into your shot in order to see what this really looks like. It's really impossible to just judge by the render alone. So I'm going to try turning up this alpha a bit, and then I'll run a render of the sequence to see what it looks like in motion. And to render that out, let's go back to our mantra ROP and go to that Images tab. And if you really just want to see this temporarily, you could render this to mplay with that button there. But I pretty much always render everything to disk rather than rendering to mplay. So let's set the frame range to a strict frame range. I'll shorten this to only go to 1070 for the purposes of our test. And I'll set this image location to jobs, image, and I have this test particles folder here. And I'll write that to testparticles.$f4.exr. And then render to disk. Now our sequence has finished rendering, and this is looking pretty cool. As I pointed out before, this looks far heavier in the color channel versus the alpha, so we can look at the alpha to get that better representation of how heavy this will be in the shot, and this looks pretty decent as a starting point for that gritty, dirty type of sim. Now this works really well to kind of fill out other debris layers, so you can mix this with RBD debris or instance particle debris, and good destruction work really comes down to just layering up multiple elements to just expand on that level of realism and level of detail. This can be useful for both wide shots and close-up, although I'd say it might be a bit more useful the closer up the shot is. But this layer isn't always included. I've done many destruction shots that haven't included these point particle passes, so don't feel like you always 100% need to use it. Often the determining factor in whether or not I add this will be how covered up this might be with dust. If this shot is going to be covered up by lots of heavy dust, then I might be less inclined to include this particulate layer. Although sometimes it can look really cool if you use your dust sim to advect some particles so that the particles follow along with the dust sim with the same sort of motion, and that can really add a nice level of detail as well.